This is Mohit, and I'm working as an ETL developer with Complaint Info Systems. Today, I'll be giving a session on Apache Kafka and how we can use it for data integration using Talent. I'll get started. As per definition, Apache Kafka it's a streaming service, a message streaming service, which uses publish and subscribe messaging system for the message streaming. And if we go one by the definition, it is a distributed message streaming system, right? So if we go by definition one by distributed, what it means is, so basically a database, it is a central storage system. So if the database is down, then we are unable to retrieve records, and if it crashes, then we might lose all of our data. But a distributed system, we have the same data distributed over multiple storage systems. In case of Apache Kafka, they are called brokers, which have partitions. We'll cover that later on. So in a distributed storage system, we have the same data which is available in different systems. If one of the systems or the storage system is down, then we can retrieve the data from another storage system. So by distributed, that it we mean that we can retrieve the data at any time from different storage system. And by message streaming, it simply means that it does not operate on the data, or it does not change anything. It just streams the data. By message streaming, we can say messages or payload or data, whatever. All three things are synonymous here. By message streaming, it simply means that it takes data from one source and transfers it to a different source. Right? So where it comes into picture is, suppose we have multiple sources. Like suppose we have three sources here, right? And these are the receivers, or where the data is to be transferred, right? So suppose if this one source is sending data to all of these four different sources, right? So it will make connections and to all these different sources. It will be transforming data. Suppose it's sending JSON to one receiver and it is sending XML to another receiver, so it transforms and whatever changes it is doing to that data. So all of those things it has to do, and it becomes very complicated. And when more sources come into play, then these connections and this process becomes very complicated and very tightly coupled. So to address this issue, message streaming comes into the picture, basically. So instead of making connections directly to different sources, all of these multiple sources, they will just send their data to one message streaming platform, right? Which in this case is Apache Kafka for us. So it will just send their data to one message streaming platform, and all of these sources then will consume or receive the information from that message streaming platform, right? So I'll start up with the presentation here. Actually, I found a pre-made presentation, so it fits my purpose. I'll start with this. I mean, to explain the concept of how message streaming enables this decoupling, so I'll use this diagram first. So suppose we have in here producers are basically different sources, right? So if we see here, we can get data from any of these sources, from multiple devices which are connected to internet, or suppose from stock market we are getting real-time data, and from databases also. So any of these sources can be we are calling them producers here, right? So there can be multiple producers as we have in this diagram here. And this Kafka cluster, for now let us consider this as the message streaming platform that we have here. And these consumers are different sources, that different receivers that are consuming the data, basically. So it decouples the complete process, and it reduces the number of connections that were initially being made, and it just transports the data from one place to another. It does not mediates with it, and it does not change anything into it, right? So in this manner, it makes it highly scalable and very efficient in processing the real-time data and using making use of it. So just to give an example, so suppose if there are three source systems like we had here and four consumers, so in this case we would have 3 into 4, 12 connections in total, right? But if we have a message streaming platform in between now, in that case we would only have a total of 7 connections, right? 3 connections these sources will be making to the message streaming platform, and 4 connections these receivers will be making with that message streaming platform. So right now we have reduced the number of connections by 5, but if we take big enterprises which have thousands of sources and thousands of consumers, in that case we literally reduce the number from suppose 20,000 to down to 300 in that case. So that's how it becomes highly scalable and very efficient in transforming data. The PPT now. Basically, Apache Kafka is a platform, message streaming platform, distributed message streaming platform, which uses publish and subscribe messaging system. We will get to the publish and subscribe part later, how it uses that. And it takes data from one source to another simply. So as I have explained, we can have multiple producers. We can receive data from different sources in real time, and we call the sources producer in Kafka's terminology, and it writes to the Kafka. So we have the Kafka is a server basically. Kafka basically uses Scala and Java. It supports Scala and Java as its languages. So we can download it from here, and it's simply we can run it using scripts as a server. I mean, wherever on our system or on the client side, wherever this server is or this service is deployed. So it runs there, and we can reach this platform using the IP address and the port of that machine basically. So I'll get to that part later. So this Kafka server, it has this cluster, and this is called Kafka cluster, and it is divided into different brokers. I mean, these are all configurable, and each of these brokers has a retention time to basically retain the messages that it has received, right? And we can also configure the local storage or the storage of each of these brokers, right? So whole of this cluster, it is divided, and that distributed part, how it comes into picture here. So suppose we have further this broker is divided into partitions actually. So right now I'll just explain it like this. So suppose one piece of data is stored on broker 1, right? And same piece of data we can store on broker 2 as well by replicating it. Later on, if broker 1 is down for some reason, then the source can consume from broker 2, and in that way we won't be losing the data, and the consumer will be able to retrieve the data regardless of downtime of one of the brokers. So that's how it enables the distributed part in the message streaming. And the receivers are called consumers in Kafka's terminology. So continuously it is polling messages from these brokers, and in case of here we can say that different sources, it can be the BI part or data analytics, or we can simply have processes like talents which are modifying the data, and then I mean the data integration part, that can also be the consumer here. Okay, and as long as this server is up, Kafka cluster is up, it will keep on streaming the messages real time, and it will keep on pulling the messages, or whatever producer is sending the message to the streaming site, it will continuously keep on publishing that message, right? And whatever consumers are subscribed to this Kafka cluster, they will continuously poll those messages. So this is the basic architecture, and as I have explained before, we can have multiple producers and we can have multiple consumers. And this message streaming part, this is the Kafka cluster, which is divided into multiple brokers, which are again multiple storage, distributed storage systems. Now, what this Zookeeper is, this is actually this we can also call it as a Zookeeper cluster or an ensemble. This is another server which actually monitors the Kafka cluster. So this Kafka cluster, after every few seconds, that is configurable. So after every few seconds, it sends its status back to this Zookeeper ensemble. And this Zookeeper 1, 2, 3, these are just nodes. Simply, we can call these nodes. So one node manages one Kafka cluster. Okay, and that one Kafka cluster can have multiple brokers, and it is further divided into more sections. We'll cover that later. So each of these Kafka clusters sends back, after a few seconds, it sends back its status to this Zookeeper, and we can separately monitor the status of this Kafka cluster, how it is, if what is down and what is working, and all of these stats using this Zookeeper cluster. So each of these is installed separately on the machine. We install that the Apache Kafka server, and we install the Zookeeper server, and there are config files for both of these. We configure them accordingly, and for suppose for Apache Kafka, we whatever properties were the retention times that we covered before for storing the messages, and also the storage space, and all of these properties that are configured in the config file, and the server is started. And similar for Zookeeper, we configure some properties and the server is started using a simple command line interface, or a terminal in case of Linux. So we can monitor these using that interface. And how we use it in Talend, I'll cover that later on. Basically, in Talend, we either act as a producer or a consumer, but we can also create topics inside these brokers. Topics are nothing but different. We can understand topics as different tables. Like we have separate tables like employee table, salary table. So we can understand topics as tables inside these brokers. I'll cover that later on, and also the Talend functionality, how we use Apache Kafka in Talend. So as I explained before, it enables the decoupling of producers and consumer by reducing the number of connections that we were making, and also making this process less complicated, and it makes it highly scalable. So without any downtime, we can keep on adding more producers and more brokers or storage systems and more consumers. So it can keep on running, and we can add on more producer brokers and the consumers, and it makes it highly scalable. So if I have to give an example, so Netflix is using this Apache Kafka framework architecture, and initially when it started, it had around 3,000 brokers. It started with 3,000 brokers, and currently I think it has more than 2 lakh or 3 lakh brokers in place. So it keeps on, as per usage, without any downtime, it keeps on adding and makes it very highly scalable in that case. And as I explained, failure of consumer does not affect system, and failure of a broker also does not affect any system, because we can have we can replicate the data in multiple brokers, and like like we see here. Uh, so suppose consider this group. It has two consumers here, right? And this group is uh, polling messages from these two brokers here, and both of these have same data. So in case one of these is down, then it will be able to fetch the data from the other one in this case. Okay. And as I was covering earlier, so Zookeeper is for this cluster management and failure detection and recovery. That is, whatever stats the Kafka cluster is sending back to the Zookeeper. I mean, monitoring that, we can detect failures and recovery. And yeah, it is an open source project. It was developed by LinkedIn, but it was made open source later on. And as I mentioned, it is distributed key value. So Zookeeper stores all that information which it gets back from the Kafka cluster in a key value pair. So while monitoring, whatever information is received back from Kafka cluster, that is in a key value pair basically. The configuration information is also stored. So I mean, if we want to look into the configuration, suppose how many brokers and how many partitions each Kafka cluster has, what is the retention period. So all those configurations are also maintained in the Zookeeper. So we can also, in the command interface, we can also look at that. And I'm not sure about ACLs. And as I mentioned, highly reliable distributed coordination. So since we have multiple brokers, as I explained, and data is distributed, so and reliable, because if one is down, then we are able to retrieve information from the other one. So it enables that functionality. And as I explained, we have multiple nodes in Zookeeper cluster or an ensemble, and each one of them has a different has one Kafka cluster, and together they form an ensemble or a Zookeeper cluster. Now, topics are, as I explained, we can relate to them as tables basically. So whatever producer is sending data, they get to decide what topic they want to send data to. So suppose I want to send this piece of information to employee topic. This piece of information is concerned with the employees. Then I send. Suppose I named a topic as employee, right? So I will send data to employee topic, and this topic is inside the broker, and it is replicated, suppose, in different brokers. So whatever consumer is seeking information regarding this specific topic, so they will only look for that information and retrieve that. I mean, yes, as similar to what we have in database, it is a logical representation of data to categorize the information so that it is quickly and easily retrievable. Yeah, and we can have unlimited number of topics inside a partition. So as I was explaining earlier, we can have n number of topics as per the requirement, and these are all associated with these partitions. And furthermore, they are inside the partitions, they are divided into these segments. Now we can configure the distribution of these different segments, but if we don't configure it, then it manages this in a round robin fashion basically. So it will pass on first information. Suppose we have 5 records, 5 rows containing data of 5 employees. So we send it to this topic C. Suppose this topic C is employee topic. It will furthermore divide it into different partitions, right? And every partition will then segment that information. And if we don't configure how we want, which partition we want to assign, or how we want to retrieve that later on, so there is a term called offset. So if we offset, suppose we set that first piece of information will be available at partition 0, and after that we offset it by 3, then next piece of information will be available at partition 3, right? So if we configure it that way, then it will be later on it will be retrievable in a similar manner. Otherwise, it will just store it in a round robin fashion, like 0 and then 1 and then 2. It manages it itself basically. It must be only in specific cases as per the requirement. Yeah. So as I was explaining before, in Kafka cluster we have different brokers, and different brokers will have different partitions because data is replicated and distributed, and all of these partitions 0, 1, 2, they all belong to topic A, and they are distributed in different brokers. So suppose if broker 101 is down and the consumer is taking data from broker 101 and 102, it will still have that same piece of information available from partition 1, right? This again explains the offset principle, and I mean, similar to how we use in we send data using REST services or AWS, we have metadata or the headers in the payload, and we have the value inside the body, and we can send data in any format. And because this message streaming service does not transforms or processes that data, so it simply passes it on in whatever format we set it in, string or XML. And usually, I mean, the data is configured in this manner. So I was explaining earlier, brokers manage these partitions, and the messages are spread across these partitions. And if we provide this offset, then each message is identified using this offset. If we don't, then it assumes that it is in the arranged in a round robin fashion, and it retrieves the data based on that. So I mean, this is the retention policy. Apart from the timing, how long we want to retain that message, so it also enables us to how we want to retrieve the messages, and that is also functionality. It is available in the components in Talend. Show them later on. So this is basically the message. If you want to see it as the message streaming platform, and these producers are making connections with this message streaming platform, and later on the consumers retrieve or pull the messages from here, and producers send data to brokers, and then later on broker or the storage system manages how these partitions uh, are actually distributed between different brokers. It is the same replication principle as I was explaining. So this partition 0 has same piece of information distributed in different replicated actually in different brokers for data retrieval, and producers write data as messages. As I was saying, messages, data, and or payload or records. It is synonyms here, and it can be written in any language. I'm not familiar with the load balancing here, how it functions. As I mentioned, producer posts the data to a specific topic as per the information, specific information, and similarly for consumers, we have to define from which topic we'll be that consumer will be fetching the information from. And as I explained that there can be n number of topics, we can have as many topics as per the requirements, and it continuously pulls the messages, principle of offset that I was explaining. So if we set the offset to 3, then based on that it will look for the distributed data as per the offset, and where in which partition it is stored. For scalability, as I explained, without any downtime, we can add on using the command line interface. We can add more brokers or more partitions in the brokers or more topics as per the requirements, and the rest of the process goes on. The server is up, but we can keep on adding as per the requirement, and that makes it highly scalable. Move on to Talend now. So we have in the jobs we have different components here for Kafka. So we can actually create topics ourselves. So suppose the versions we can select from here, and for the port we actually provide the, suppose for my system it would be localhost if I have the server on my system. If it is on some other server, then I provide the server IP and followed by the port number, right? And here I can create topics as per my requirement. So suppose I'm designing an integration job, right? Talent is acting as the producer here. So here I can create the topic first. Suppose it would be employee. Server is up, suppose on my machine, right? Kafka server is on. Zookeeper server is hosted, and I have created uh, a broker. All the configurations. Suppose I have created one broker and it has one partition and also all the policies. So before posting any data, I could create my own topic here, right? And I can pass this replication factor, that is into how many brokers. If I have three brokers on that Kafka server, I can actually have pass this number as 3 here, and it would have the same data replicated on all three brokers. Or I can set the number of partitions in which I want to distribute this data, right? These are configurable here, and I can also set the retention time for how long that message will sit in that broker before it is being pulled for creating the topic. And if I want to later on, after creating the topic and uh, generating the data that I want to post to that message streaming platform or to Apache Kafka server, right, I will pass the name of the topic that I have just created, the IP and the port, and if I have any authentication or any SSL on that server, that setting I will pass here. And simply this will then talent will act as the producer. So I have these in line, and this will act as the producer in that case, and it will post data or write data on that Kafka server. And if I want to create talent as a consumer in that case, then I will have t Kafka input. Sorry, in that case I will have t Kafka input here, and here I'll specify from which topic I will be fetching the data from. Again, the broker list will have the local the IP. I'll write IP here and the port number, right? And consumer group ID, if it is created, suppose there are three consumers that are in one consumer group, and I can configure from how many brokers that consumer group will be retrieving the data from. So if we come here, so suppose this consumer group has three individual consumers, right? And they are fetching data from different brokers. So in this case, if the broker 1 is down, then it will be able to fetch the data from this broker N here, so that the downtime or the unavailability of one broker does not affect uh, the the functioning of this consumer. So for that, if it is enabled, or if we have this consumer in a consumer group, then we pass it here, right? And if we have enabled a offset setting that I explained later, so explained earlier, basically we can offset by how many number of partitions we want to retrieve data. If that setting is enabled, so we can write it here. Thank you.